Hi, pre-algebra students. This is the first lesson of chapter 6. So in 6.1, we're going to talk about functions. So what is a function? What are some different ways to represent a function? So as it states right here, one way to represent a function is using an ordered pair. So ordered pairs show us inputs and outputs. And if you look at all of the inputs and think about what relation or what do those have in common in the ordered pairs, hopefully you noticed that all of the inputs are the x values. And when you look at all of your outputs, those are your y values. So if you think about a little function machine, it's like if you take, let me fix that. You take a little number and you put it in an equation. So if x is your input, so let's just give x an easy value. So if we give an x an easy value, like 2, and let's say our function, which can be written as an equation, is y equals x plus 2. So you would take 2 and put it into your function in place of x. So when x is 2, the output value is 4. So when the input is 2, the output is 4, and we can represent that by using an ordered pair, 2, 4. Okay, so in our key idea, it shows the definition of a relation. A relation just means that two things are paired together. So we're pairing an input with an output, and we've already talked about one way to represent the relation is using an ordered pairs. Another way is shown right here. It's a mapping diagram. So notice that the inputs are still those same x values that you see over here in the ordered pairs. The outputs are the same y values. And it's just an organizational method. So it shows these ovals around the inputs and the outputs, and then we use arrows to show a connection between the input and the output. So it's just, a method of representing a function that you need to be able to recognize. So down here in example 1, we have some mapping diagrams. So it says list the ordered pairs shown in the mapping diagram. So remember, my inputs are my x values and my outputs are my y values. Ordered pairs always are written in the form of x comma y, and please put parentheses around your set of ordered pairs. So notice my first pairing is 1, 3. Then I have 2, 6, 3, 9, and 4, 12. Okay, so that one was pretty simple. You have 4 inputs and 4 outputs, pretty easy to match up. In example B, this one's a little bit different. So notice we only have 3 inputs or 3 x values this time, but we have 4 outputs or 4 y values. So you have to pay a little bit closer attention to where your arrows are and how those are connected. So notice the input 0, sorry about that. The input 0 is connected to the output 0. So my first ordered pair is 0, 0. The input 2 is paired with the output 1, and it's also paired with the output negative 2. So we have 2 ordered pairs containing the input 2. Sorry, and then there's one more there. That last one is the input 4 and the output negative 3. So we have 4 sets of ordered pairs, even though we only have 3 inputs. Okay, so you can pause the video at this time and try the on your own, or you can come back to them later, but please make sure they're finished before class. We're going to move on. So we have a definition here. Our definition is called a function. So that's, again, the main idea of this entire unit is based on functions. So a function is a type of relation that pairs each input with exactly one output. And notice I'm highlighting the important part of the definition there. Each input can only have one output. So you can have something that's a relation, but it's not necessarily a function or a functional relationship. So let's look at some examples down here. So in example A, it says determine whether each function is a relation. And again, notice we're looking at some mapping diagrams. So anytime you want to know if something is a function, you're asking yourself, does each input have one and only one output. So I'm looking at my inputs. The input -9 has one output, 0. -2 has one output, 5. 5 has one output. And 12 has one output. So I would say yes, this is a function. So notice it is okay for two inputs to share the same output. But again, going back to that definition, they can only have one. Let's look at example B. So in example B, -2 has one output, 4. -1 has one output, 3. 0 has two outputs, 5 and -6, or 5 and +6, sorry. So without even moving any further in the mapping diagram, I'm going to say no. This one is not a function. It is a relation. It does show a relationship between inputs and outputs, but it is not a function. Okay, moving on to example C. This one says plug -2 and +2 in for x in the equation y equals x squared. So really what they're asking us to do here is to evaluate the function. Okay, so let's first evaluate the function when x equals -2. So when x equals -2, y is equal to -2 squared. Notice I put parentheses around the -2 because if it says x squared, that means I'm squaring the entire base. So remember, that means -2 times -2, which is +4. So when x is -2, y is +4. When x is +2, when you plug that into the function, y is equal to 2 squared, and 2 squared is also 4. Okay, so the point of this is to make sure you recognize that whether you're squaring a -2 or a +2, both of those are going to give you a +4. So just be careful when you're doing those evaluation problems. All right, in example 3, we are going to describe a mapping diagram. So it says, consider the mapping diagram at the right. First, determine whether the relation is a function. And looking at that, again, I'm going back to my definition. Does each input have one output? And I would say yes. Each input has exactly one output. Okay, and then it says describe the patterns of inputs and outputs in the mapping diagram. And your hint is to look at the patterns going down the table. So what's happening is you move down the table, and then what's happening is you move from the left to the right, from the inputs to the outputs. Okay, so if you look at, let's do the first one, looking down the table. So remember, inputs are your x's, outputs are your y's. And as I'm looking down the table, each time x is increasing by 1. And over here, each time y is increasing by 15. So one way to describe the function in words is as x increases by 1, y increases by 15. Okay, you could also use the words input output as the input increases by 1, the output increases by 15. Okay, so the second thing we're going to do is look at across the table. So how could I write a rule? So far we've written description in words. How can I write a rule that's what's happening from the inputs to the outputs? So how do I get from x to y? So if you look, I think if you multiply here by 15 each time, sorry about that, like 1 times 15 is 15, 2 times 15 is 30, 3 times 15 is 45. So as a rule, I can say 15 times x is equal to y. Or you could say the input multiplied by 15 equals the output. Okay, so once again, pause your video or finish these up before class tomorrow, but you're going to do the on your owns at the end of the video, and then you'll be finished and ready to go for tomorrow. Thank you. Have a great night.